Okay, so if we continue where we left off, we have to remember that we had the head of the radius proximal, the head of the ulna distal. Remember, we had notches that were concave in nature and heads that were convex in nature. And I alluded to the fact that there was a proximal radioulnar joint and a distal one. So we're going to have a brief discussion here, slides in regards to those two joints. So let's do the proximal radioulnar joint first. This is the one up by the elbow. Of course, this is a pivot joint, which allows pronation and supination, and it's within the joint capsule. And this is the articulation of the radial head with the radial notch of the ulna. Now, we have to remember that the distal surface of the head of the radius is also concave to articulate, of course, with the capitulum. So we have to remember that's happening at the same time as this proximal radioulnar joint occurring. So this is the radial head with the radial notch of the ulna. If you remember, we did talk about the annular ligament last week, and this annular ligament is a U-shaped fibrous collar, and it attaches to both the anterior and posterior margins of the radial notch, right, that the radial head sits in. In other words, the annular ligament holds the head of the radius in position. And because the radial head spins in pronation, supination, and I sort of alluded to this last week, this annular ligament is lined with synovial membrane. Therefore, it's part of the capsule of the elbow, which continues below the annular ligament as the sacciform recess. So we can see here in the diagram, here we've got the synovial membrane here. We have the annular ligament holding the head in, and then we have this part of the synovial membrane that slides out from under the annular ligament. You can see it much better here, and this is known as the sacciform recess. And there are other sacciform recesses in the body, which we'll get to. So again, you can see there's ligaments in this drawing. So of course, underneath these ligaments, you'd find the fibrous capsule and the synovial membrane. So we don't see them here, but we do see the annular ligament here, again attaching to both the anterior and posterior aspects of the ulna, thus surrounding the head of the proximal radius with this slight bit of a synovial membrane sliding out underneath, which of course is the sacciform recess. We do have, and if we remember this, of course, that we've got for example, biceps brachii here. Remember that it is a supinator when the hand is in pronation. So what's happening is, if you remember from the slides last week, in the anatomical position in pronation, the distal radius rolls over and lies anterior to the distal ulna. For that to occur, the radial head needs to be able to spin here. And of course, that spin is held in place by the annular ligament, but also remembering that the radial notch of the ulna takes in the head of the radius. Now, it's a synovial joint, so we already know that there will be articular cartilage within the area of the head of the radius. And of course, the radial notch of the ulna will also be lined with articular cartilage with an associated synovial fluid and so forth within the context of the synovial membrane. So the annular ligament slides in around behind. So it is lined with, the annular ligament is lined with synovial membrane. So it's a part of the capsule of the elbow. And of course, the annular ligament it's an intrinsic ligament, does associate a bit with the fibrous capsule of this area as well. Other ligamentous structures we find here, of course, we've already talked about the interosseous membrane. And this is, again, a fibrous sheet that lies between the interosseous borders of the radius and ulna. Remember that it attaches to the medial aspect of the radius and the lateral aspect of the ulna. And this does allow movement between bones, and it does provide a very large surface area for attachments for muscles. When you get to sort of joint mobilizations in this area, you'll get a sense of how much movement it does allow, especially at the distal radioulnar joint. The next one is called the quadrate ligament, somewhat square in nature, and it lies between the radial notch of the ulna and the medial surface of the neck of the radius. So we can see here's the quadrate ligament right here, right? Quite deep underneath here. We can see it lying underneath. So of course, here's our annular ligament here that's been cut in the diagram. We see the exposed radial head that would sit in here, and of course this annular ligament is lined with synovial membrane as part of the synovial membrane of the whole, both the articulation between the trochlear notch and the trochlea of the distal humerus, the elbow joint, as well as this area here within the radial head as it relates to the radial head of the proximal ulna, which allows the spin. We can see at the floor of this articulation between the radial head and the annular ligament within the radial notch, we have this quadrate ligament, which controls over rotation, is basically what it allows. It does allow for rotation to occur, but not to over rotate. So you can see it's been removed here, but here you can see how it tucks up in underneath here. So it allows for the rotation to occur in pronation, supination, but not excessively. So you can see here the ligament has been removed, but you can see the head of the radius here as it relates to the radial notch of the proximal ulna. This, of course, is, it would be your long head biceps tendon here that's been cut away, but you can see how in the supinated position, in the anatomical position, they lie parallel to each other. And in pronation, there's been spin of the radial head, and the distal radius has crossed over and lies anterior to the ulna. Okay, the next one is called the oblique cord. This is considered to be somewhat insignificant and therefore not always present, but it's basically a fibrous cord that runs at an oblique angle to the joint itself. You can see it here. The next is the distal radioulnar joint. It too is a pivot. This is the articulation of the head of the ulna with the ulnar notch in the distal end of the radius. What is the distinct difference here? When we look at the proximal radioulnar joint, it is the radius that spins within the annular ligament and the radial notch. When we look at the distal radioulnar joint, it is the distal radius that spins around the head of the distal ulna. So the radius spins proximally, and the proximal radius spins within the articulation of the radial notch of the ulna and the annular ligament, whereas the distal radius, instead of it spinning in one place, it actually spins around the head of the ulna. So we can see it here in this diagram. You can see when we look at the head of the ulna here and the distal radioulnar joint, we can see in the anatomical position where the distal radius sits in relationship to the ulna, and then it spins around the head of the distal ulna to end up in the pronate position. Again, let's remember, the ulna doesn't move other than flexion of an extension because of its articulation of the trochlea in the trochlear notch. So in pronation supination, it is only the radius that's doing any movement. In pronation, it rolls over the distal head of the ulna, the distal head of the ulna, to lie anterior to the ulna. In supination, it rolls back over the head of the distal ulna to lie parallel to the ulna. So within this articulation, this distal articulation, it's pivot, but in a slightly different way, as I just explained, we also find an articular disc in here. And this is located at the distal end of the ulna, and it attaches at the medial edge of the ulnar notch of the radius to the lateral side of the base of the styloid process of the ulna. So we can see that the disc, right, is right here. So again, taken away, we can see it lying under here, right? So this is the distal radius. Out here is the lateral aspect. Here's the ulnar notch for the head of the ulna. And we can see that part of the head, ulnar head, it is articular. And we can see cartilage here. And this distal head of the ulna, part of it lies within the ulnar notch of the distal radius, but part of it articulates also with the articular disc. Again, it's a synovial joint. So here we can see it reflected open and see the two aspects of the disc and the head. Here we can see it all put together, where again the ulna is sitting in the ulnar notch of the distal radius, and we can see that the capsule is here and the articular part of the head of the ulna is sitting within or on top of the disc, and we can see associated ligaments here for the time being in the moment. So in another way you can look at it is we've got the hand here with the carpals, and you can see that the distal radius is here. You can see the placement of the articular disc. So we're going to learn when we get to the wrist joint, the distal radius articulates with the proximal row of the carpal bones, but the distal ulna does not. There is a disc between the head of the ulna and the carpal bone, so it sits right in here. So the distal ulna does articulate in the ulnar notch of the radius, but the distal ulna does not articulate with the proximal row of the carpal bones. It articulates with the disc that we see here. So the articular disc is located at the distal end of the ulna. It attaches at the medial edge of the ulnar notch of the radius to the lateral side of the base of the styloid process of the ulna. The proximal surface articulates with the head of the ulna. Therefore, the joint cavity is an L shape in the coronal cut, and we can see it right here. You have this L-shaped articulation. The upper part of the L is where the head of the ulna articulates in the ulnar notch of the radius, again a synovial joint. We also have the lower part of the L where, again, the head of the radius articulates with the articular disc directly. So therefore we have this L shape. The disc, it helps unite the structures of the distal radioulnar joint a little bit stronger. Remember, we have to have a bit of a different stability at the distal radioulnar joint because we have this very large bone, the distal radius, that is spinning around the smaller distal part of the ulna, which is the head. The second thing it does separate the cavity of the distal radioulnar joint from the cavity of the wrist joint. As I said, the distal ulna does not articulate with the proximal row of the carpal bones of the wrist. And the third thing it does, it provides articular surfaces for the ulna and the carpal bones. So because the convex nature exists for the distal head of the ulna, you can see how that wouldn't fit. You would have a convex surface of a distal ulna trying to articulate with a convex surface of a proximal row of carpal bones. It doesn't work. So you get a nice congruent fit here of the head of the ulna into the ulnar notch of the distal radius, but you do need this disc to increase congruency between the distal head of the ulna as it relates to the convexity of the proximal row of the carpal bones. Okay, so it does provide a better, more stable articular surface. The capsule of the distal joint is, of course, the fibrous capsule encloses the joint, and as usual, because it's synovial, it is a synovial joint. So, of course, the synovial membrane lines the fibrous capsule and the proximal surface of the disc, and it does extend a little bit proximally as a sacciform recess of the distal radioulnar joint, and this allows a larger, more loose sort of configuration of both the proximal sacciform recess and the distal. It allows a looseness that provides for the amount of movement that occurs at both these joints, which results in both pronation and supination, which we can see here. So you can see here in the diagram, you've got, a number of different things. Here's your joint capsule, and you can see how the disc fits in. Here's your ulna and radius and so forth. You get the idea of how it all sits together. So what occurs here? When we look at its two movements in pronation, we know that the palm is turned posteriorly in the anatomical position, or inferiorly, of course, when the elbow is flexed to 90 degrees. Supination, of course, the palm is turned anteriorly in the anatomical position, or superiorly when the elbow is flexed to 90 degrees. Basically, what happens is the radius rotates proximally within the annular ligament and distally around the head of the ulna. That's the distinct differences between the two. So again, we can see our pronator teres and our pronator quadratus and our supinator, and you can see the roles it plays here. You can also see here is the head of the radius way up here at the proximal radioulnar joint. Here is the distal part with the head of the ulna as it sits in the ulnar notch of the distal radius, and we can see how it spins around. This is a lovely diagram here that shows you the positions of the ligaments and what they allow for. Again, where the position is of the distal radius as it relates to the head of the ulna as it moves through its positions of pronation, mid-rotation, and supination. Okay, thanks for this slide set. We'll continue on. These aren't too bad. I'll certainly get these all done and be prepared for the midterm next week. Thanks again.